All right, for our selected slide this week, we're looking at different types of precipitation and basically why does it look like what it looks like when it falls here at the surface. We have a couple different types of precipitation: rain, sleet, freezing rain, snow, and then hail, and we'll go through each of these. And what it looks like to us here on the surface is largely dependent on the cloud temperature and what our atmosphere looks like from the bottom of the cloud down to the Earth's surface. With rain, we can have two scenarios: either a warm cloud to start with and a atmospheric profile temperature that is above freezing from cloud base down to the surface, which would be fairly typical in the tropics, or we're looking at a cloud base that might be cold, but as we move towards the surface, like in our image here, we are warming up below freezing, so we have solid precipitation that's melting to a liquid, and then we see it here as a liquid. Snow, as we would expect, is coming from a cold cloud where it's solid precipitation, and then it remains cold the whole way from the bottom of the cloud to the surface, so it remains solid, and then we see it here falling as a solid. Sleet or ice pellets are transparent or translucent pellets of ice. They tend to be fairly small, less than 5 millimeters in diameter. Now, this is very different than hail, and we're going to talk about hail here in a second, but A, it's going to be much smaller, and B, it's going to be much clearer because it freezes much faster, and so it ends up being much clearer than we typically see. What we're seeing with sleet is we start with a cold cloud. Part of our atmosphere from cloud base to kind of, we'll say, middle ground here is still cold, but it's going to fall through a warm layer, as we can see in that diagram on the right, turn into a liquid, but then at the very bottom of our atmosphere, above our surface, it's going to pass through a cold layer again, and so it freezes back up very quickly, and that's how we get that little pellet that we see. Freezing rain is a very similar procedure. However, at this point, it stays through a much larger, warmer layer, and then at the surface, it's falling through a much colder layer. Sometimes it's even just hitting the surface that's below freezing. And so when it hits the surface, it's going to instantaneously freeze and give us this nice, what they call glaze ice that we're seeing. Compare the two, we see them side by side. Notice the difference in warm layer and how much wider it is with freezing rain than it is with sleet. And notice then, as we get close to the surface, how small or how thin that freezing layer is for the freezing rain versus the sleet. One of the other things to think about is if you're outside during either of these, freezing rain will hit you as a person as a liquid, sleet would hit you as an actual ice pellet. And so there is that difference there as well. Now, hail is its own special type of precipitation, and it's only going to occur when we have a large thunderstorm cloud, typically a supercell, where we're having updrafts and downdrafts. And when this happens is we tend to have a tall enough cloud that we are having part of the cloud be below freezing or warm, and then part of the cloud that's below freezing, which is very cold. And so we get water droplets and ice droplets that are existing together. And so what happens is our little water droplet gets pushed through the updraft into the top of the cloud, or where it's below freezing, it freezes, gets pushed down by the downdraft, will run into non-frozen water droplets, and so it will grow in size, and then will get pushed back up by the updraft again. And it can keep going around and around and around, depending on how strong the up and the downdraft are. The stronger the updraft is, the larger hailstones are going to be. So if you ever see kind of golf ball sized or baseball sized hailstones, you know the storm was pretty strong, because basically it's going to keep going around until it is heavy enough to overcome that updraft and fall out the bottom of the cloud.